I just realized that I had turned off the camera, so I'm saying this again, just for those of you who want to see this again. So we have a rectangle. The base will be on the x-axis, and the other two, the upper vertices, will be on this parabola. So now I need to graph the parabola. I know how to graph it because this is x squared. Negative x squared is this. And 4 minus x squared is up 4. So I know that it will cross at 2 and negative 2. And going up 4. So this is the case. So this is the parabola y equals 4 minus x squared. Again, x squared minus x squared minus x squared plus 4. And I know that when I set this equal to 0, it has to cross at negative 2 and 2. Now let's talk about this rectangle. It says that the upper vertices are somewhere on this parabola and the base somewhere on the x-axis. This is one option. Here's another option. And I can continue forever, but I don't want to put more into here, right? So the question is, what will be the dimensions? What are the length and the width of this rectangle so that we maximize the area? I don't know. So in order to maximize a function, I have to have the function. If I don't have the function, then I have no clue how to proceed. So the key is, as we always do, a figure. So now I have the idea. So if I go with this, then I'm really looking at this area. I don't know where the points are. I have to determine the height and the width of the rectangle. That will maximize the area. So my first step is a picture, so I can analyze, or I see what the situation is. In number 2, of course, I have to create this function. And in number 3, I will find the maximum of this function. From that moment on, it will be a piece of cake because I can use calculus to do that. But how do I determine this area? Okay, so I'm going to denote this by x, and I'm going to denote this by y. So the base of this rectangle, so the area, for now I may have to use 2 variables, so I'm not going to write anything else, just area, is base times height. So if this is x, the base is twice x, and the height will be y. But what is y? For any point on the parabola, the y is this. Okay, so then I know that this is a function of x and of x alone. I put it in the correct order. Always remember, factor simplify. Do not accept negative leading coefficients when you solve an equation. Do not accept anything but descending order. So I'm hoping that you're getting into these habits. So 2x times x squared is 2x cubed. 2x times 4 is 8x. And this is a piece of cake now, because when I determine the area, the maximum, I have to find a prime, no problem. Negative 6x squared plus 8. I have, like before, find a critical number. This is always defined. So x squared will be 8 over 6, right? Negative 6x squared equals negative 8. I divide. So this will be x equals plus or minus the square root of 4/3. And you can say, well, the length cannot be negative, and I will have to agree. So I will say x equals the square root of 4/3. Because it's a length. Okay. So now in the next step, I have to convince you that this gives a maximum. Who knows? I didn't convince you of anything. I only said that this is a critical number. But I didn't show you that this gives a max or a min. I have no idea. So then in the next step, I have to show you that this gives a maximum. And if I can't, then I'll go back. So 0, of course, it cannot be infinity, but you know what I mean. The square root of 4/3, this is 0. And now I'm checking my first derivative. When I plug in 0, I get positive. When I plug in, so remember, the other solution is here. So when I plug in whatever, 10, it will be negative. So now this is guaranteed to give a maximum. So the base of the triangle is twice that. Base to the square root of 4/3. And I can approximate it. About the height is y. So it's 4 minus 4/3. So this is 3 minus 1 is 2, so 8/3, right? 3 times 4, 12 minus 4, 8. Okay, now what is the, if they are asking us to find the maximum area, no problem. I have the length and the width. I don't even have to go back to this function. The maximum area is base times height. 2 the square root of 4/3 multiplied by 8/3, whatever that is. If you want, you can go back here, but it's the same thing, because that's how we got the area. And that would be here, the maximum. I chose a nice problem for a change. Very good, good pick of the topic.
I have a quick question.
Sure. On this problem?
Yeah, something similar. So what would we do differently when they ask to maximize compared to minimize?
Nothing. You have to show what it is.
Okay, I see.
That's why I insist, if you don't show this, I can't give full credit. Because finding the square root of 4/3 doesn't mean anything. It's just a number. But you have to show that this number gives a maximum. If you don't show that it gives a maximum, then you're not telling me anything. Since I don't like to just leave the squiggles in there, I'm going to just take the square root here of 4 divided by 3. So I got here 2.31. And this multiplied by 8 and divided by 3, I got 6.16. I had a professor who would say, from this point on is messy, you do it. I can't do that to you. Good. Anything else?
Maybe we can do one of those problems that has the different parts, like when is the particle in motion, when does it start, stop, change directions, like all that.
Sure. Do you have one in mind?
I can't remember which chapter.
It's chapter 3 at the beginning. At the beginning of 3.7, I believe. I thought we did all of those. I don't remember if there is anything left, but we can. Yeah. I can make something like that on the spot. Make it up on the spot. So we have 1, 2, 3, and 4. I think we did. I'm not sure. I don't remember. Any preference?
I guess not.
Do we remember at least which one we did so we don't do it again? Or we want to choose one that we do it again? And I don't remember which one. Do you want to do the radical function?
So we did t squared e to the negative t.
Yes, that was 4.
That
Good.
was the one we did.
That's the only one we did?
And 80t minus 16t, if that's also there.
No.
Right.
So there is a sine pi t over 2, and there is a 9t over t squared plus 9. And a polynomial.
Let's do 2 then.
Number 2, 9t over t squared plus 9?
Yes.
Okay, perfect. Good pick. 235. And that is f of t, 9t over t squared plus 9. Perfect. And first question, so just remember that the function is in feet and t in seconds. I cannot forget that. I have to write them down. Find the velocity. So the velocity of t will be f prime of t. Leave 9 alone, patiently waiting. T prime is 1, t squared plus 9 minus t times 2t over t squared plus 9 squared. For some reason, this rings a bell. I think we did it, but it doesn't matter. So negative 2t squared plus t squared is negative t squared plus 9 over t squared plus 9 squared. Negative leading coefficient, I'm hoping you already became allergic to it. And of course, I'll factor that. Good. Okay, so we found the velocity. We already prepared it for what follows because we know what the question is asking next. And it says find what is the velocity after 1 second. So the velocity after 1 second. Number 2, v of 1. Okay, 1 minus 9 is negative 8. Negative 8 times negative 9, positive 72. Divided by 1 plus 9, which is 10, 100. So this is going to be 0.72 feet per second. What is the particle? When is the particle at rest? We already knew that. The velocity is 0. I already know. T equals 3, t equals negative 3, which cannot be accepted because this is in seconds. When is the particle moving in the positive direction? So I have t. Of course, it's not infinity. So v of t. So v of t is 0 at negative 3 and 3. I should have not removed because so this is always positive. So I'm not going to even look at it. It's a waste of time. So when I plug in 0, this is positive, this is negative, but negative times negative will be positive. And when I plug in 10, this is positive, but there is a negative in front. So according to this, the particle is moving in the positive direction between 0 and 3, and thereafter in the negative direction. Then find the total distance traveled during the first 6 seconds. So total distance between 0 and 6, there will be the absolute value of s of 3 minus s of 0, minus s of 0, and then plus, because they want 6, I'm going to change this to 6, plus s of 6 minus s of 3. S of 6 minus s of 3, an absolute value. So now I have to put this function in and plug in 3 and 0 and 6. So I'll share my screen, and with the graphing calculator, clear everything. That was a masterpiece. I really didn't want to, I wanted to keep that there forever. So 9t divided by t squared plus 9. And I plug in 0 and 3 and 6, and I copy. S of 3 is 1.5 minus 0 plus S of 6, 1.2 minus S of 3, which is 1.5. Okay, so let's see what we get. Of course, the first one will be positive because the function is moving in the positive direction. And this one will be negative 0.3. That's why I have to put the absolute value, so plus 0.3. So this will be 1.8, and this is in feet. Find the acceleration at time. Okay, so I will differentiate this for the acceleration, not this and not that. Negative 9 will wait patiently. The top prime is 2t times t squared plus 9 squared. Minus t squared minus 9 times, watch me run out of room, 2 t squared plus 9 times the inner function prime, always times the inner function prime. Okay, so if we don't simplify by factoring, we're not going to get anywhere. So we have to simplify by factoring. Okay, so I would factor out a 2t goes outside, another t squared plus 9. 2t is out, t squared plus 9 is out, there is 1 left in. 2t is out, this is out, so these two are out. So I have 2 times t squared and 2 times negative 9 with minus in front. Okay, now I do this. Negative 18t. Negative t squared plus 27. Always check my numbers, don't let me make errors here. Sometimes I talk and write and the arithmetic is, as you noticed, a couple of times. So keep an eye on what I'm doing. Of course, I'm allergic to this. I hope you are too. So this is t squared minus 27 over t squared plus 9 to the third. So I don't know what they want, but when the acceleration is 0, will be a t equals 0 and a t equals plus or minus the square root of 27. Only possible is the 27, the square root of 27 seconds. But I have to write this because this equation has two solutions. Okay, find the acceleration we did, and also they say the acceleration after 1 second. So 18 minus 26 over 1,000. 1 plus 9, 10 to the third. So this is negative, what is it, 18 times 26. I got 468. So 0.468. And remember, this is in feet per second squared. Feet per second. I just want to make sure that I wrote the measurement unit. I did. So this is negative 0.468 feet per second squared. Of course, it's an acceleration. Okay, what else they want? Okay, the last one is when is the particle speeding up and when it is slowing down. And of course, they are referring to 0 to 6 seconds. So I'll go back and squeeze in here my acceleration. Or maybe not. I'm just going to copy it again. Why? I'm going to copy it here. But it needs to be together.